Good morning to all of you. Let us start the next topic of the chapter Motion in a Plane. So, today I am going to cover the projectile motion, equation of projectile, equation of path of projectile, time of flight, maximum height and range and range for complementary angles of projection. So let us understand projectile motion. Now, projectile. What is a projectile? An object that is in flight after it being thrown or projected is called a projectile. So everything whichever you throw in the space and which does not move and which moves under the effect of gravity only is known as a projectile. For example, if you are throwing a stone in the upward direction, then it is a projectile. If you are throwing a stone from a building in the downward direction, then it is a projectile. But plane is not a projectile because it is not moving under the effect of gravity only. It has its own acceleration. So projectile motion. The motion of a projectile which is in flight after it being thrown or projected is called a projectile motion. It can be understood as the result of two separate, simultaneously occurring components of motion along x and y axis. The component along the horizontal direction x-axis is without acceleration, and the component along the vertical direction y-axis is with constant acceleration under the influence of a gravity. So the motion of the projectile in the two direction, x component as well as y component. X component without acceleration and y component under the acceleration, constant acceleration equal to acceleration of gravity. In our study, the air resistance is negligible and the acceleration due to gravity is constant over the entire path of the projectile. So let us discuss the equation of a projectile motion. Suppose that projectile is launched with velocity vb that makes an angle theta naught with the x-axis. V naught, that is the initial velocity. So let us consider that projectile is launched with initial velocity v naught and making an angle theta naught with the x-axis. This is the diagram of the projectile. So v naught is the initial velocity and it makes an angle theta with the x-axis. Now acceleration always acts in the downward direction that is along y-axis. So we can say that vector A is equal to minus j cap, because along the y-axis the unit vector is j cap. So we can say that it is minus g because it is in the downward direction. So minus j cap. Acceleration acting on the projectile is due to gravity which is directed vertically downward. So vector acceleration A is equal to minus j cap. Or we can say that ax, that is x component of acceleration, is equal to 0 and y component of acceleration is equal to minus g. The component of initial velocity v naught r. These are the two components along x-axis, that is v naught cos theta naught, and along y-axis, that is v naught sin theta. Now v naught x, that is the x component, Vx cos theta naught along y-axis, that is v naught y, is equal to v naught sin theta naught. If the initial position is taken as the origin O, then x naught is equal to 0 and y naught is equal to 0. Therefore, from the second equation of motion, x is equal to x naught plus v naught xt plus half ax naught t square. This equation will reduce to x is equal to v naught xt is equal to v naught cos theta naught t, because along x-axis ax is equal to 0 and along y-axis this will reduce to y is equal to y naught plus v naught yt plus half ay t square. This will reduce to v naught sin theta naught t minus half gt square. The component of velocity at time t are. Now these are the components of the initial position, x-axis, along x-axis and along y-axis. These are the components of the velocity. Now let us discuss the components of velocity at any time t. At any time t, that is using the first equation of motion, v is equal to u plus at. So vx is equal to v naught x plus axt. This will become vx is equal to v naught x because ax is 0 and vx is equal to v naught cos theta 0. So this is the velocity at any time t. The second equation, vy is equal to v naught y plus ayt, and that will become vy is equal to v naught sin theta naught minus gt. So using the equations of motion, first equation, second equation, we have written the x component and y component in using the second equation, first equation and second equation of motions. Now the same thing can be represented in this diagram also. Here this is the initial velocity, the component of the initial velocity. At any time the component of the initial velocity, at the highest point the y component will become 0, and only we will have the x component. Again at this point we will have the two components, at this point we have the two components of the velocity. Note, the horizontal component of velocity remains constant throughout the motion, but the vertical component reduces to 0 at its peak of the path and again increases in the opposite direction. The magnitude of velocity of the projectile at any time t is given by vt is equal to under root v naught square cos square theta naught plus v naught sin theta minus gt square, because v is equal to under root vx square plus vy square. So x component square plus y component square. The direction of velocity of the projectile at any time is given by direction tan beta is equal to vy upon vx. So vy is v naught sin theta naught minus gt upon v naught cos theta naught. Now equation of the path of a projectile. The shape of the path of a projectile can be found by mathematical equation. Now from x is equal to, from this equation, x is equal to v naught xt is equal to v naught cos theta naught t, we get t is equal to x upon v naught cos theta naught. And from the equation y is equal to v naught sin theta naught t minus half gt square, this will reduces to, now putting the value of t in this equation means from this equation we got t is equal to x upon v naught cos theta naught. Put this value in this equation, so this will reduce to y is equal to v naught sin theta naught into x upon v naught cos theta naught minus half g t square, that is x upon v naught cos theta naught t square. So on simplification this equation reduces to in this form. Since g theta naught and v naught are constant, so the above equation can be written in the form y is equal to ax minus bx square, where a is constant, that is equal to tan theta naught, and b is another constant equal to g upon 2 v naught cos theta naught square. So we can say that this equation, this is the equation of a parabola. So we can say the path of the projectile is a parabola. Now time to reach maximum height and time of flight of a projectile. Let us find. Let Tm be the time taken for the projectile to reach its maximum height and capital T be the total time of flight of the projectile. At the point of maximum height and at t is equal to Tm, we know that vertical component of the velocity Vy is equal to 0. So in this equation, Vy is equal to V naught sine theta naught minus Gt. This will reduce to 0 is equal to V naught sine theta naught minus Gtm. And from here we can get Tm is equal to V naught sine theta naught G. But at T is equal to Tf, that is the total time of flight, Y is equal to 0. So from this equation, Y is equal to V naught sine theta naught T minus half Gt square. This will become V naught sine theta naught T f, that is the total time of flight, minus half GTF Tf square, and on reducing we get Tf is equal to 2V naught sine theta naught G. And also now here just look at these two equations, that Tf is equal to 2Tm because of the symmetric nature of the parabolic path. So here note one thing, to find the maximum time of flight we can write only these two equations. If we do not want to find out these, then for the examination purpose you can use only this much, that is T is equal to Tf and Y is equal to 0. Then this equation you can get the total time of flight. Or if you are doing this one, then simply you can say that by the symmetric nature, the total time of flight Tf will be is equal to 2 Tm. So this will reduce to 2 U naught sine theta naught upon G. Now maximum height of a projectile. Let Hm be the maximum height of projectile after time Tm. Then from the equation Y is equal to V naught sine theta naught T minus half Gt square, putting these values in place of Y, that is the highest point Hm, V naught sine theta naught T, and for T, for the highest time taken to reach highest point, is V naught sine theta naught upon G minus half G V naught sine theta naught upon G square. Simplifying, we will get that Tm is equal to V naught square sine square theta naught upon 2G. So this is the expression for the maximum height of a projectile. Now after, at Hm the maximum height of the projectile Vy is equal to 0, that is the velocity at that point is equal to 0. So from this equation, Vy square is equal to V naught square sine square theta naught minus 2Gy. This will become Hm is equal to V naught square sine square theta naught upon 2G. Means to find the maximum height, either we can use this derivation or we can use this. So in either way we can find the expression for the maximum height of a projectile. Now range of a projectile. Let the range of the projectile after time Tf, that is the total time of flight, it is the horizontal distance covered by the projectile from its initial position 0, 0 to the position where it passes Y is equal to 0. Therefore, x is equal to V naught xt, this is equal to V naught cos theta naught t, becomes r is equal to V naught cos theta naught tf, that is the total time of flight, because the range means Y is equal to 0, so only the x component will be there. So x component is V naught xt, and t, in place of t we will write the total time of flight. So by putting the value of the total time of flight, this will reduce r is equal to V naught square sine 2 theta naught upon G. Now sine 2 theta naught is the algebraic is the trigonometric expression which you have learnt in the previous class, that is sine 2 theta is equal to 2 sine theta cos theta. So using this expression we reduce this expression to this, so we get range is equal to V naught square sine 2 theta naught upon G. Note that the range will be maximum for the maximum value of sine. That is when sine 2 theta naught is equal to 1. This is possible, therefore sine 2, and this is possible when theta naught is equal to 45 degrees. So therefore we can say the maximum horizontal range is equal to V naught square upon G. When theta naught is 45 degree, then H maximum becomes V naught square upon 4G, that is the maximum height, and range becomes 4 times of H maximum. So at theta is equal to 45 degree, the range becomes 4 times the height of the 4 times the maximum height. Now range of the projectile is same for component angles of projections. Let us find out this, that we know that r is equal to v naught square sine 2 theta naught upon g. So if at angle 45 degree the projectile is thrown, then path is equal to this. This is your r maximum. If we increase the angle, then the range decreases. Now from this figure it is clear that for the two angles, that is this graph and this graph, for these two angles the range is same, that is this one. Only the maximum height differs. So the range of the projectile is same for the two complement angles of the projectile. Let us see mathematically. That is for angles 45 degree plus alpha and 45 degree minus alpha. 2 theta is 90 plus 2 alpha and 90 minus 2 alpha separately. So the value of sine 90 plus 2 alpha and sine 90 minus 2 alpha are the same and are equal to cos 2 alpha. Therefore, the ranges are equal for elevations which exceeds or fall short of 45 degree by equal amount of alpha. So we can say the range of the projectile is same for the complement angles of the projection. Means suppose if a projectile is thrown at an angle 30 degree, then it will have some range, and the complementary angle of 30 degree is 60 degree. So if we throw an object with initial angle 60 degree, then again it will cover the same range. The only difference will be in the maximum height. In other words, the complement angle of the elevation, the ranges will be the same. That is for theta naught and sine 90 minus theta naught, the values of sine 2 theta naught and sine 180 minus 2 theta naught are the same. So thank you. That is all for today.